1. Clashing branes. Could our universe be a membrane floating in higher dimensional space, repeatedly smashing into a neighboring universe? According to an offshoot of string theory called brane world, there are large extra dimensions of space, and while gravity can reach out into them, we are confined to our own brane universe with only 3 dimensions. Neil Turek of Cambridge University in the UK and Paul Steinhardt of Princeton University in New Jersey, US, have worked out how the Big Bang could have been sparked when our universe clashed violently with another. These clashes repeat, producing a new Big Bang every now and then, so if the cyclic universe model is right, the cosmos could be immortal. 2. Evolving universes. When matter is compressed to extreme densities at the center of a black hole, it might bounce back and create a new baby universe. The laws of physics in the offspring might differ slightly, and at random, from the parent, so universes might evolve, suggests Lee Smolin of the Perimeter Institute in Waterloo, Canada. Universes that make a lot of black holes have a lot of children, so eventually they come to dominate the population of the multiverse. If we live in a typical universe, then it ought to have physical laws and constants that optimize the production of black holes. It is not yet known whether our universe fits the bill. 3. Superfluid space-time. One of the most outlandish new theories of cosmology is that space-time is actually a superfluid substance, flowing with zero friction. Then if the universe is rotating, superfluid space-time would be scattered with vortices, according to physicists Powell Mazur of the University of South Carolina and George Chaplin at Lawrence Livermore Lab in California, and those vortices might have seeded structures such as galaxies. Mazur suggests that our universe might have been born in a collapsing star, where the combination of stellar matter and superfluid space could spawn dark energy, the repulsive force that is accelerating the expansion of the universe. 4. Goldilocks universe. Why does the universe have properties that are just right to permit the emergence of life? Tinker with a few physical constants and we would end up with no stars, or no matter, or a universe that lasts only for the blink of an eye. One answer is the anthropic principle: the universe we see has to be hospitable, or we would not be here to observe it. Recently the idea has gained some strength, because the theory of inflation suggests that there may be an infinity of universes out there, and string theory hints that they might have an almost infinite range of different properties and physical laws. But many cosmologists dismiss the anthropic principle as being non-science, because it makes no testable predictions. 5. Gravity reaches out. Dark matter might not really be stuff, it could just be a misleading name for the odd behavior of gravity. The theory called MOND, modified Newtonian dynamics, suggests that gravity does not fade away as quickly as current theories predict. This stronger gravity can fill the role of dark matter, holding together galaxies and clusters that would otherwise fly apart. A new formulation of MOND, consistent with relativity, has rekindled interest in the idea, although it may not fit the pattern of spots in the cosmic microwave background. 6. Cosmic ghost. 3 mysteries of modern cosmology could be wrapped up in one ghostly presence. After making an adjustment to Einstein's general theory of relativity, a team of physicists found a strange substance popping out of their new theory, the ghost condensate. It can produce repulsive gravity to drive cosmic inflation in the Big Bang, while later on it could generate the more sedate acceleration that is ascribed to dark energy. Moreover, if this slippery substance clumps together, it could form dark matter. 7. It's a small universe. The pattern of spots in the cosmic microwave background has a suspicious deficiency: there are surprisingly few big spots. One possible explanation is that the universe is small, so small that, back when the microwave background was being produced, it just could not hold those big blobs. If so, space would have to wrap around on itself somehow. Possibly the oddest suggestion is that the universe is funnel-shaped, with one narrow end and one flared end like the bell of a trumpet. The bent-back curvature of space in this model would also stretch out any smaller microwave spots from round blobs into the little ellipses that are indeed observed. 8. Fast light. Why do opposite sides of the universe look the same? It's a puzzle because the extremes of today's visible universe should never have been in touch. Even back in the early moments of the Big Bang, when these areas were much closer together, there wasn't enough time for light, or anything else, to travel from one to another. There was no time for temperature and density to get evened out, and yet they are even. One solution: light used to move much faster. But to make that work could mean a radical overhaul of Einstein's theory of relativity. 9. Sterile neutrinos. Dark matter might be made of the most elusive particles ever imagined, sterile neutrinos. They are hypothetical heavier cousins of ordinary neutrinos and would interact with other matter only through the force of gravity, making them essentially impossible to detect. But they might have the right properties to be warm dark matter, buzzing about at speeds of a few kilometers per second, forming the largest dark matter clumps mapped by recent observations. Sterile neutrinos could also help stars and black holes to form in the early universe, and give the kicks that send neutron stars speeding around our galaxy. 10. In the Matrix. Maybe our universe isn't real. Philosopher Nick Bostrom has claimed that we are probably living inside a computer simulation. Assuming it ever becomes possible to simulate consciousness, then presumably future civilizations would try it, probably many times over. Most perceived universes would be simulated ones, so chances are we are in one of them. In that case, perhaps all those cosmological oddities such as dark matter and dark energy are simply patches, stuck on to cover up early inconsistencies in our simulation.